By this time, you know all sorts of ways to factor. Easy ways, hard ways, short and long ways. Let's review some of the methods we saw earlier. Common factoring was the simplest. Just take out whatever is common to every term. Common factoring was always the first thing to try on any problem, and it still is. Don't forget it. And then there were trinomials, something like this. You remember, in this case, you look for two numbers that multiply out to -20 and add up to -1. Or you might just guess until you get to the harder ones, like this. It's harder because of that 6 in 6x squared, but it's still a trinomial. You may need to practice some more of these or review some earlier modules. These two will fill you in on all the missing steps for problems where you can't just look and guess. But assuming that you've got all that straight, one of the special shapes you learned about before was called difference of two squares. Pretty simple. Both terms are perfect squares. But it had all sorts of clever disguises. Look closely at this one. Here we want to write 3xy squared in place of a, and 4a to the fourth b to the fifth instead of b. Once we recognize that we really have a difference of squares, factoring is pretty easy. Just like a minus b, we have both of the expressions in each bracket, one with a minus sign, one with a plus. Be sure you recognize the pattern. Now that was a difference of squares. What do you suppose happens if we have cubes, powers of 3, instead of squares? It doesn't fit any of the patterns we've seen, but there is an answer. This is, in fact, a difference of two cubes. And here's the formula for factoring a difference of two cubes. You'll probably want to memorize it. And don't worry about where it came from. Just check it out and be sure it works by multiplying it out again. Just use your distributive law. Or you could do it by using long division. We did one like this in the module on long division. That way you'll actually discover the formula for yourself. But what we're really after here is to use this formula in solving other problems, some of them heavily disguised, like this. First, we have to recognize the two cubes. Then we copy the factor formula. Every place the formula has a, we put p cubed. And every place it has b, we put 3q to the fourth. The same trick we used with difference of squares examples. As always, you can check that it's right by multiplying it all back again. But the key step is the first one. Recognize the disguise. You have to spot those cubes. Now here's one for you to try. Start by spotting the cubes. Find the factors and then come back. So, how can I figure this out? I need to find my a and b. I notice that the exponent can be divided by 3. Any exponent that you can divide by 3 represents a cube, and there are lots of cubes here. And of course, I have to do the actual factoring. There are two steps to these problems. The recognize step, where you realize you're dealing with cubes, and the factor step, where you copy the basic pattern and substitute. Okay, so what if instead of a difference of two cubes, we have a sum of cubes? You guessed it, another formula, similar to the one we just used. Watch out for those signs. They're almost the same as before, but not quite. Be careful. The process of using sum of cubes is just like what we saw with the last formula. Try it out on this one now, and then come back and we'll check your answer. First step, recognize. So what do our A and B look like here? I find out by dividing the exponents by 3. Notice that 4 cubed is the same as 64. Second step, factor. So I complete the factoring, and once I've recognized the A and the B, I can substitute them into my factoring pattern. So we've got the same two-step process for all these factoring shapes. Step 1, recognize, and step 2, factor. It's that simple, as long as you've memorized the shapes that make it work. Here are some of them now. And while you're at it, remember, some shapes just don't factor, no matter how hard you try. Here are a few to keep in the back of your mind. The last two are the other bracket in your cubes formula. Now we get to mix up these new ideas with all the old ones. It's a good plan to have a list of all the possibilities and be able to recognize them. That first step, recognize, is really what makes it all work. Now let's take everything we know and apply it to this one. Think about what shape it might be. What's the pattern? Can we recognize it? Sure, we can write it as a difference of cubes and factor it using the formula we just learned. Remember, A is x squared and B is y squared, but we're not finished yet. Look at that first bracket. Do you recognize a pattern? Of course, it's a difference of squares. So we split the first bracket into two parts. Then the second bracket. It doesn't look too friendly, so let's leave it for a moment while we back up a little bit. Maybe we can find an easier way. When we first started factoring, we shifted our original expression to a cubes shape. Could we have written it as squares instead? Yep, that works too. Let's see what that does. We can factor this time as a difference of squares. But again, we're not finished. Each of these brackets is one of our new friends, cubes. We get 4 brackets all multiplied together. For lack of space, we've written them on 2 different lines here. Two of the brackets are what we got before, and the other two must be factors of that strange bracket we left earlier. That was a hard one. You need lots of practice right now until you're really comfortable with this kind of problem. I'm sure you remember that factoring pops up in the middle of all sorts of other problems, like equations or fractions. So practice or read some more first. And before you go, here's one last problem to try. Study the problem and then use any of the 6 methods you know for factoring. Come back as soon as you have your answer. Well, this is not like anything you've ever seen before. The secret here is a simple one. Don't forget common factors. Remember the very first factoring we learned. I take out that 2ab because then I see a sum of cubes, so I can factor again. I recognize the cubes, so I can substitute into my pattern with ab and with 2c, and that's it. Now do some more on your own. After a while they may even be fun, and they'll certainly be useful. Good luck.